Today, we will talk about solving rational equations. To solve a rational equation, what we'll do first is find an LCD and multiply everything through by the LCD. Then we will get rid of fractions, and we must always check for those extraneous solutions that will give us a denominator of 0. In our first example, we want to find an LCD, and that LCD is 2x. Next, we want to multiply each fraction through by the LCD of 2x. And that is what we see here. As we can see, we're going to have some things that will cancel out. The 2's cancel there, and the x's cancel in the last ratio, which will leave us with 6 minus x equals 24. Now we're going to solve the equation as we've been taught in previous math courses. And our solution is x equals negative 18. We must check to see if this is a true solution or if it is an extraneous solution. So we replace our x's with negative 18. And we see that it checks. Our solution is negative 18. In this example, of course, we want to find an LCD, and that LCD is x plus 1. So now we're going to multiply everything in our fraction through by x plus 1. And once we do that, we see that the x plus 1's cancel there. Nothing cancels in the second term, but in the last ratio, the x plus 1's cancel. And we're left with this equation. And now we have no more denominators, so we can solve this equation as we've been taught to solve it in previous math courses. And x is equal to negative 1. And of course, we want to check our solution. And when we do a check, we see that when we replace the x's with negative 1, we get a 0 in the denominator. And so we have an extraneous solution, so therefore we have no solution for this equation. In this example, we need to get an LCD, but before we do that, we want to factor first to help us get our LCD. So now it's been factored, and we'll get an LCD, and our LCD is x plus 2 times x minus 2. Next, we will multiply everything through by the LCD. And when we do that, we see what will cancel. And of course, all of our denominators should cancel. And this is what we're left with after we do all of the multiplication. Now we want to start to combine like terms and then move our terms around so that our equation is set equal to 0. So now we have a quadratic equation that we can factor. We divided everything through by 2, or you can take a GCF out. That's 2. And now we factor that quadratic. We set each factor equal to 0. And we get x equals negative 3 or x equals 1. And we want to check our solutions to see if we have any extraneous solutions. And so when we check our solutions, we see that both work. So negative 3 and 1 are both of our solutions. All right, so what happens when we just have two ratios set equal to each other? We can take a shortcut. And that shortcut is just to cross multiply as if you were solving a proportion. So here's our first example. We're going to cross multiply 1 times x squared plus 4x, and then 3 times the x plus 4. And once we cross multiply, we want to use distributive property, and then we're going to set our equation equal to 0, and we're going to factor. And our solutions are negative 4 or 3, and we need to check to make sure those are really our solutions. Well, when we check, -4 does not work, but the 3 does. So our only solution is x equals 3. In this last example, pause the video and you try to do it on your own. Hopefully you've worked it out. So now let us check to see if you've done it correctly. Now, why did we cancel out the x plus 1? Because x plus 1 is on both sides of the equal sign, so we can cancel out the x plus 1. Now we divided everything by 2, and now we use distributive property and then move 3 to the other side, and we're going to factor. And now we're going to check our solutions. X equals -1 does not work, and x equals 3 is our only solution. Okay, so at this point, write down 3 questions that you may have. If you have more than 3, then of course write more than 3. Tell me 2 things that you've learned about solving rational equations. And then write 1 thing that you feel like you will need to watch out for as you're solving these equations.